Since the translators have been doing hard work today, I'll do this one in English. That's good? Okay. Okay, that's good. So, hi everyone. As you heard before, I'm Prat. I'm the founder of Tehiru Aerial Systems. I'm here to share with you a highly effective airborne interception system we designed in the past 2 years. This system is actually reshaping modern warfare, and would like to discuss that. But before I start talking about myself and my gang of engineers and drones fanatics, since history repeats itself so many times, let's talk for a moment about history. So history tends to outshine a few famous characters, but actually put some other very interesting ones in the shadow. So with hands, everyone, who here knows the Wright brothers? Okay, 60%. And how about Glenn Curtiss? Anyone here knows Glenn Curtiss? Look at this, one person. Okay. So just so you know, the Wright brothers, they were the first people on Earth to fly. They're a legend. Now, Glenn Curtiss, he was a motorcycle racer, and he was an aviation enthusiast. He embodied curiosity, embodied iteration, and self-relentless problem solving. So he became one of the fathers of naval aviation. Now, unfortunately, the Wright brothers and Glenn Curtiss were locked in a bitter competition. The Wright brothers focused on their patents. They focused on the legal suits that they can make on anyone that infringed their patents. And while they were focused on that, Glenn was focused on building, demonstrating, and executing much more scalable airplane manufacturing system. Now, this competition, it actually slowed down the US aviation development to a point where Europe were better for a few on that part. Now, even though Glenn Curtiss and the Wright brothers connected around 1926, this was really slowing down the US up until World War I. World War I forced everyone, it reminds you of something we had lately, right? It forced everyone to drop legal actions and start working on things that are actually working right now for the war. And the US did not build new factories from scratch. They reused automotive plants, they reused farm equipment, and even appliance factories. They reused them, and when the designs fit the reality of manufacturing, that's when production exploded. And the cool thing is that Curtiss moves forward so fast, and all of these upgraded facilities at the end of the war, they flipped back for civilian use. And all of a sudden, cars became affordable. Not because people are rich now, but because production in scale drove costs down. So a little bit about me. I had just returned from the US when the war began. I was leading the Uber autonomous vehicle development in the US, and I was also working on a new reusable launch system, launching satellites to space. And what we've been doing is designing a launch system that is launching like a rocket, but lands like a drone. So this was a drone, 2.4 tons worth of a drone that is landing. And when the war began, October 7th, the war forced us to transition from working on the future of humanity, working on where humanity goes and do things better than they do on Earth, and we're forced to start doing tactical drones. Of course, with the goal to help Israel, to help our nation and our people stay alive, we started using off-the-shelf hardware and we build drones very fast and integrated on them our own software stack. Now, all of this happened while I'm carrying my own core mindset of building technology, something I call the 100 hertz culture. 100 hertz means 100 times a second. That's how computers think, and that's how my team works, at 100 hertz. Decisions, iterations, and execution all happens much, much faster. We must move forward, especially when we're during a war. So with volunteers, with engineers, with students, with PhDs, and drone enthusiasts, we repurposed our orbital launch subsystems and turned them into a system of tactical 3 kilograms attack drone. So this drone includes encrypted communication system that was designed to go to space. It includes vehicle control. Remember, I told you 2.4 tons drone landing. This was turned into these small dudes. With that, weapon activation system, igniting explosives, path planning and autonomy. All of these things went into the first 3 kilogram tactical drones. And with our values of speed, accuracy, and cost effectiveness, we'll speak about it in a moment, we managed in a matter of weeks to start supplying the Army with hundreds of attack drones. Now, Curtis' scalable manufacturing mindset has been central to Tehiru's strategy, and that helped us to meet the urgent requirements of the war at the beginning, of supplying hundreds of drones, and later develop a truly low-cost interception system. It's important to say that moving forward, nations that will continue spending $100,000 to stop a $1,000 threat, they will lose the fight before it even began. It's important to note the battlefield is shifting from very expensive vehicles, a big F-35, it's shifting to hundreds, if not thousands, of simultaneous small threats. So a drone cannot cost more than $3,000. This is super important. And apart from this, another thing we learned is that with this scale, we're talking about thousands, with this scale, manual is not going to work. Piloting of drones will work in edge cases, but if we want to defend our skies, it must be fully autonomous. So integrating all into one system, we're building it in a way where we do not do front-end system. What we do is we provide an API that gives you access to our systems. So if you have a detection system, speak with us through an API. We will send an interceptor to take down the target. So everything led us to develop an autonomous interception suite, which, like I said, it integrates with radars and optical systems around the world. This system is called Shark Suite. The Shark Suite system is an autonomous detection-to-strike system, and it provides advanced protection for a broad amount of critical infrastructure. It can be a base of the Army, it can be our borders, and it can even be a data center and a power plant. All of these things are going to need support, and I would like to take you through these 4 phases of detect, attack, identify, and neutralize. So let's do this. The detect phase is the first phase of this system. This is when the radar system is detecting a target. It sets a target, and it sends it to us. We then allocate interceptors and triggers an autonomous launch. Once we're airborne, we're moving to the track phase, which is a high-frequency guidance algorithm that updates the trajectory of our interceptor in real time. As new telemetry comes in, it brings us up to the identify phase, where we are exactly in front of the target. We're 500 meters from the target, and the system is handing off control to onboard equipment. We have sensors, and we have ML classifiers that are detecting, verifying, and locking on the target. Once target is locked, we're moving to the neutralize phase, which is our sensors on board. Once detected, what they do is they start a terminal guidance that aligns the interceptor with sub-degree accuracy. What I want to do now is show it to you in action. What you'll see here is the point of view of the target, and you can see it working. In a moment, our interceptor will fly very fast towards the target. Take a look. So this is the last frame. We didn't stop the video. It's the last frame because we demolished the target. You can see it here on the right. The interceptor flies in and take it down. So we're doing this day in, day out. We're actually doing it right now in the south of Israel, demonstrating the system. So this architecture is a stepping stone to unlock the next era of edge-based aerial autonomy. Drones think, coordinate, and act. And that can be anywhere on the planet. So what did we speak about today? Autonomy is no longer optional in the scale and speed of the threats we have. Edge computing is our new cockpit. It makes decision at 100 hertz, and it reduces a lot of the communication we need. Interceptors must be fast, they must be accurate and affordable, or we lose before we launch. And scalable designs, it means no fancy hardware, no good-looking machine. Some are looking for that. We need a working system, and this is what's defining the next generation of warfare technology. When we look back at aviation history, one thing becomes clear. Innovation creates legends, but scale actually changes the world, which is what we want. That's the difference between the Wright brother and Glenn Curtiss, and this is the difference between traditional defense systems and what Tehiru brings to the table. We have the privilege of writing the next chapter in the history of aviation, leading the shift from manually controlled, expensive drones to a network of intelligent, self-reliant aircrafts making real-time decisions. And finally, as autonomy rises from our sky to space, one thing is clear to me. The future belongs to those who command the air and space above them. So please, if you didn't, come and meet us in our booth, and thank you for listening.